does food influence disease? You might have been told that your diet is the key to good health. And if you search, there's an overwhelming amount of health advice. Yet almost 2 out of 3 adults are overweight or obese, and the prevalence of type 2 diabetes is rising. My name is Sarah Lewis, and I'm researching how our bodies, and specifically the liver, process diets in ways that lead to obesity and diabetes in hopes of treating metabolic disease at the University of Wisconsin-Madison. In my own family, I understand how serious and scary a condition like type 2 diabetes can be. Today, we want to present a framework for how we can all think about diet. First, I'll discuss food and its relationship to metabolism. Next, I'll discuss the role of the liver and why this can be a source of metabolic disease. Finally, I'll tell you about what some of the research means for you, and present a framework for thinking about diet. So when you think of metabolism, you might be thinking in terms of a fast or slow metabolism, perhaps referring to how well a person maintains or loses weight. From a biological standpoint, metabolism is a sum total of chemical reactions necessary for an organism to live. You can think of your body as if it's a factory with a goal of survival. Metabolism would be all of the daily operations in that factory. To run this factory, you require food that is fuel for energy and building blocks. Your factory stores extra energy for later use. Your tissues, organs, and systems would be departments that do specific work to aid in your survival. Now imagine in this factory that there's a 24-hour energy processing plant. This is your liver. When you eat food, it's broken down into different molecules that the liver uses to manufacture a sugar called glucose. And this glucose is shipped throughout the body for energy via the circulatory system. Now the liver takes its orders from a messenger called insulin, and then it can indirectly respond to the amount of glucose in the blood, which depends on when, what, how much we've eaten. When we eat, insulin encourages the liver to produce glucose. When we've had too much glucose in the blood, the liver is told to package the excess glucose together so that energy can be stored. Finally, when you have a low glucose, say after a fast, the liver can unpack the stored glucose and send it where it's needed. This is how the liver normally functions. But metabolic diseases occur when the processing plant is overloaded with too much fuel. Remember, a functioning liver will not shut down production, so it adjusts. For instance, obesity occurs when the liver can no longer store glucose and converts to excess fat. This fat is then shipped to other parts of the body, including fat tissue, for long-term storage. In some cases, this excess fat can also be stored in the liver itself, and this is known as non-alcoholic fatty liver disease. Over time, too much fat in the liver means that the liver is no longer able to respond to insulin, its messenger. So imagine a processing plant that is so full of storage that even the mailbox is full and a message can't be received. When this occurs, you are insulin resistant and blood glucose levels remain high even when you haven't eaten. This is type 2 diabetes. These diseases can all occur due to environmental factors and genetics, but remember, the major input is food. In my lab, we are researching how long-term diets, high in carbohydrates or sugars, leads to diseases, and we're identifying molecules that are involved in disease onset. The bad news is that the diets we study are designed to mimic Western-style diets that are highly processed and full of simple sugars. But there is some good news. One, as researchers, by better understanding the processes that lead to disease, we can find treatments for these diseases in the future. And two, some characteristics of metabolic diseases can be partially, if not completely, reversed with current treatment, environmental changes, and of course, you guessed it, changes to diet. Prevention, of course, is the best method. While I can't tell you what to eat, I encourage you to think long-term about your diet in order to decrease the chance of metabolic disease. You are that luxury engine that requires premium fuel. Enjoying a sweet treat or junk food sparingly every once in a while won't wreck your engine today, but over the long term, continuous subpar fuel will cause damage. The great news, though, is that we have some control over the long-term health. And I hope you'll consider those choices today. So today I've talked about the role of food in our metabolism and how the liver processes glucose in ways that lead to disease. Finally, I talked about how what we eat in the long term, but not in the short term, is most important for metabolic disease prevention. While there is no perfect diet, I hope this talk imparts a different outlook on how you should think about diet and disease long term. Thank you.